Welcome. My name is Bob Deneau. I'm currently the STEM coordinator for the Rockwood School District, and in February at the METC conference, did a session called Beyond the Fun Factor. We had lots of folks come, and it was a great session, so I figured I would share that out with anyone else who was interested. So what we're going to do here is kind of run through that presentation, a little bit relaxed format. So the presentation before took 50 minutes. This video should be much less than that, because I won't really go through everything in nearly as detail maybe as I did, or ask questions or things of that nature. So anyway, you can see on the screen there if you want to connect with me, ask questions, share ideas. I'd love to learn from everyone else. You can primarily find me at iTechBob on Twitter, the RSD_STEM, that is our Rockwood District STEM account. And for the full presentation or any resources, you can go to bobdeneau.com, a simple Google site where you can find other sessions that I have done. So Beyond the Fun Factor is really all about taking these cool STEM tools and really going into the instructional strategies that you get the most out of them. And really, this presentation was born out of a big project that I'm working on. So I'm working on something called the Innovation Room Project in Rockwood. So we are putting in 19 innovation rooms. Think of this as part makerspace, part STEM room. And so there's all these great tools in there, and students are going to go in there and have fun. Fun is a really good thing. We're not trying to discourage fun. But what we want to do is we want to get beyond that. So when students come into these rooms, they can really be using just their teachers can give them sound instructional strategies where they can really amplify their learning. And you don't have to have an innovation room to do any of the things we're going to talk about today. The other big influence on this is I tend to check out lots of different STEM equipment, different classrooms, primarily elementary and some middle school as well. So it's something that, when teachers check it out, they talk about the students had fun. It's like, okay, well, how did we do some other things beyond that? So this is really going to be all about instructional strategies and classroom applications for popular tools that you may have, whether in your makerspaces, in your classroom, things of that nature. So we know that STEM is trendy, and that is part of the reason people are jumping on the STEM bandwagon. You hear about it in news reports. It's important stuff right now, but we want to go beyond trendy. We want to make STEM learning something that really builds a STEM culture in your classroom and in your school that really, again, isn't about the tools. It's about the thinking and the learning that is happening with them. So I want you to think about this. For the past 3 years, I've been our district STEM coordinator. Before that, I spent 8 years as a technology specialist. So I go into a coaching role very many times. And so teachers will come to me, I'll kind of give them some training, show them some tools, and then they'll use them. So I want you to think about a time when you've tried out something new, and think about, was your first reaction, my students had so much fun? I'll raise my hand there, guilty as charged. I've done that too. And sometimes that's where we get stuck. We put so much focus on the students really enjoyed this, they had fun. We don't necessarily put as much emphasis on the learning. Sometimes our first words out of our mouth is, my students were so engaged. And engagement is great. And again, we want both of those things. But what I really hope when I meet with teachers and work with teachers, the first thing I hope they say to me is, my students learned so much, and then they go into it from there, because really that is what's important. So again, that's what we're going to focus on, putting more of the emphasis on the learning and just knowing that the fun and engagement are going to come along for the ride as well. So many times when you go to a conference, some people joke that they could play buzzword bingo. So you'll see lots of cool things in the top row. You've got virtual reality, you've got different robots, you have 3D printing, and then you have the bottom row. Some of those, buzzword instructional things. So you see the Stanford Design Thinking Model on there. You see the Buck Institute's project-based learning, gold standard. You see things like computational thinking. All these things are things that are buzzing right now. That means they're popular, which there's nothing wrong with that. But I want you to think about, where do you spend more of your time, just kind of geeking out? Do you geek out over the top row, or do you geek out over the bottom row? Now, I'll admit, I'll geek out over robots and 3D printing and virtual reality a lot, but in my role in the curriculum department, I've really had to embrace the bottom row truly a whole lot more than I do the top. And that's where we want to put our focus. So it is okay to geek out on instruction too. Those of us into technology, we definitely geek out on all the cool tech toys, but it truly is, for teachers, in my opinion, we really need to put the focus and geek out on the instruction, because that is really what's going to matter. That's what's going to give us a bigger return on our investment that we're making in these classrooms and in this equipment. So it's okay to geek out there. It's okay to geek out pretty much anywhere. So I want to briefly kind of go through some of the strategies we're going to look at today. The first one is the Stanford Design Model, and you can see a link for more information on that. So if you're not familiar with this, it is a way to go about problem solving. And the one thing I really like about this model is the emphasis on empathy. And I find that empathy is a great way that we can pull in some of these STEM tools. Before students can really solve problems, they have to understand the people and places they're trying to solve these problems for. And so empathy is really the place where that happens. And I just love putting emphasis on that. It ties into our character ed things that we're doing. And no offense, we could probably use to be more empathetic towards each other. We see that in the world all the time. The other place you'll see a lot of STEM tools is in the prototyping phase. And we'll talk a little bit about that, as well as how really the STEM tools you're using may only fit into part of a much bigger project. If you were prototyping with some of these STEM tools, the rest of your learning might not happen using those tools at all, and that's perfectly okay. The STEM tool shouldn't be the focus. They should be a tool that's part of a bigger process. So this model is really good if you're wanting students to really come up with original things, and great for teachers as well. We also know there are plenty of other design processes out there. You see the engineering design process on the left. In the middle there, this comes from the book Invent to Learn. If you've not read the book Invent to Learn, a definite must if you're looking to do anything in the makerspace world. I find that middle one works really well for our younger grades, because you can really, basically, you can break it down into really 3 steps. Think, make, and improve. And sometimes for students, especially our younger ones, that's what they need. And then you'll see plenty of other cycles out there. Like, here's an example of one put out by Little Bits. And the whole thing is, you can take one of these, use it. You can also tweak it, make it your own. You know your students, you know your clientele, you know the things that are going on in your classroom. So come up with your own design model. There's plenty out there, and really part of the design model process is to really tweak and change and make it your own. So as we talk about some of these different design models, we'll kind of refer back to these a little bit as we look at some of the tools. We also know that project-based learning can be a great instructional tool to use in the world of STEM and really beyond. But when we think about STEM learning, we can use those STEM tools when we're dealing with sustained inquiry. We can use them to help generate problems and questions. We'll talk about that a little bit. And then the products that the students make. Again, those are things that they can prototype out of whatever tools that we're using. So if you're not familiar with project-based learning, the Buck Institute is the go-to place for project-based learning. So make sure to check them out. This is their gold standard. Teaching practices and design elements. So definitely do the research there before you dive in with this. Otherwise, you're going to end up having projects instead of truly project-based learning. But we'll kind of talk about that a little bit as we go. When you're doing things that probably deal more with computer science and coding, you may want to think about using computational thinking. Now, computational thinking is not limited to just computer science, but it really has many of its roots there. If you're not familiar with this, basically, there are 4 parts to computational thinking. One is you decompose a problem. So what that means is you take that bigger problem and you break it up into smaller chunks. So our students are, tasked to solve something. It may be too large for them to come up with it all on their own. So we find ways to break it up into more manageable problems that they can then deal with one at a time. So as they break up these problems, then they get into what's called pattern recognition. So if you're doing this with code, many times you're looking for patterns in the code. If you're doing this with data, you're looking for data patterns that you might see. If you're dealing with none of those, patterns can be all sorts of things. Patterns could be behaviors. Patterns could be physical things that you see, but you want to see if you can find those patterns, because once you can find those, you can figure out the relationship between them, and that's going to help you solve the problem. Then you get to what's called abstraction. This is the one that I think I struggle with the most, trying to explain this and also understand it. It's basically taking those patterns and kind of stripping out the details and just giving you kind of almost like a summary. You're really trying to create a general rule, and many times that general rule is something that can then be applied to other similar problems. And the last one you get to is algorithm, and I think, or you may see this called automation. So this is something that may trip people up. If we're doing this in a pure computer science sense, then truly we're just writing code, writing our program that's going to do whatever it is we want it to do. But algorithms don't have to be code. Code is really just step-by-step instructions that a computer is going to follow. So if you're using this to solve a non-computer science problem, algorithm might just be a set of steps or directions that you're recommending to someone, or you need someone to follow that's going to help them solve that problem. So when we get in some of the coding robot type things that we're going to look at, we'll refer back to computational thinking, or as we talk about those, think about how they might fit into this cycle. So there are plenty of other ones that are out there. You got the 5Es model. You have people who love to do design challenges. You can do more of a problem-based learning instead of project-based learning. No matter what the instructional strategy, we just want to make sure that we're providing really a chance for students to think, to be creative, and then really to create. And that's what many of these STEM tools are all about. So let's dive into our first one here. So we have virtual and augmented reality. Again, a really kind of hot topic. I want to show you this picture on the right because I love this example. This actually came from one of our local middle schools. They were having a speaker come in who had climbed Mount Everest. And so to prepare these students probably to be more aware of, and have, good insights into maybe some of the background of their speaker, they actually used Google Expeditions, and they took the Everest expedition on there so that they could familiarize themselves, with Mount Everest and what it's all about, so that maybe they could probably get a better understanding and get more out of the speaker. Now, I love this because this wasn't just doing it for fun. We have one Google Expeditions kit in our entire district, and so that thing gets checked out pretty much every single week. And the hard part about that from the teacher standpoint is, you may reserve something months out. Well, when it's coming to your classroom that week, what if you're not to a spot where it can totally tie into curriculum? You end up doing, some fun stuff. You probably do some review of old curriculum, maybe that you've covered, and, you just want your students to experience it because it's fun. But that doesn't really get us into the I need to use it then and now as a really great instructional tool. So what some of our middle and high schools have done is they rely on student devices, which you don't have to have one for every student. As long as about half your class has a device, you can pull off doing a VR activity. What I like to do in that scenario, if not everybody has one, is we partner them up, and then we'll go through the activity. We'll kind of split it, and so when one person's on VR, the other person is just kind of watching their partner, which is really kind of funny. But when they're done, the partner has to kind of explain what they were looking at. And then what we do is we see how good of a job that they did, because we'll let that partner take a look at the exact same thing. So it works on, looking for details and being able to communicate orally, but also it works on visualization for the person who does not have the device. But if you have VR devices, and again, you can set this up on kind of a BYOD setting. You can get viewers as cheap as $5. You can spend more on some of the plastic or kind of spongy ones. And if you have a tablet and you have a $50 router, you basically have created a Google Expeditions kit that normally would cost you anywhere from $7,000 to $10,000. You can create it for a fraction of that cost, maybe $600 or less, as long as you're using student devices. But that's something that can definitely bring VR into your classroom. But when you have VR in your classroom, what's tie into those instructional strategies? So one of them, we talked about building empathy in the Stanford design model. So virtual reality can be a great way to start building empathy. Let's say that we're studying regions of Africa in a geography class, and we're working on trying to solve some problems, whether it's the water crisis that's happening in Cape Town right now, or whatever that, or who knows what that problem could be. Most of our students have probably not gone to Africa. They probably don't have any experience besides maybe reading about it or seeing pictures. Virtual reality can allow us to maybe experience that information in a much more realistic way. And so I think when we see that, we can actually start putting ourselves in the position of being in that area, or seeing what a certain group of people do and how they live. And so we can start to understand them better. And so then that helps us build empathy, which we then can use for our design projects. I also like VR as a research and inquiry tool. We have students look at websites. We have students read books. Why are we not having students also research visually? Whether that's using something like a Google Expeditions, whether it's using YouTube 360 videos, or even going into Google Maps and going into the Street View, and that doesn't even require the headset. The headset always makes it more immersive, but if you research that way, then maybe that's something then when we actually do read the text or you do see videos that you have more of a background. You've built up a knowledge base that maybe that'll help you along the way. Or you're using it as an inquiry tool to learn about something, and then that's going to help you generate more questions, or maybe any questions. Because if you don't have the background knowledge, about a topic, how are you supposed to generate questions on that? So VR can be one of those tools. And eventually, I'm loving how we're seeing the creation of VR content be something students can do. And this could be something when you get into more of the prototyping phase, or the any of the design processes where you're actually making a product, being able to create something in VR. So there are several resources out there that let you do that. Google Expeditions is working on that. They're actually beta testing that out in schools right now. CoSpaces, if you're familiar with CoSpaces, that is also a creator that you can use to create virtual reality content. And then there's just some other great resources I want to point out. One of them being Creator AVR. Cool thing about this app is you can look at the same thing in virtual reality with your headset, or you can look at it with augmented reality with just your phone. We know the Google Arts and Culture app has built-in virtual reality, basically little walkthroughs in there. And pay attention to two things, one of them being AR Core and the other being AR Kit. Those are the augmented reality platforms for Google and Apple. So my guess is a year from this date, there will be so much more content out there because developers are working with those right now. But when we think about virtual reality, let's go beyond the fun and let's think of it using it as an empathy and a research tool, and eventually maybe even a prototyping tool. So during our session at METC, I kind of put in a talking thing here where people could share ideas. I would tell you, if you have an idea about how you're using VR or how you'd like to use VR, the cat's chiming in here too, so obviously she would like to talk. Send those to me via Twitter at iTechBob. I would love to get your ideas and possibly we can connect and share. So the next thing I move into is robotics. So there are lots of robotics platforms that are out there that are used at the elementary and middle school and even the high school level. We have Lego and Vex products in our school. So no matter what kind of product you're using, and if you're using something else, there are very similar activities that you can do with robotics. Again, make it more than just let's build robots and have fun. One of them that we did here, and you're seeing this at the picture on the upper right, is actually what we call simulated activities. So we did this with fifth graders. They were studying space, and they were actually talking about the Mars rover Curiosity. And so we actually see that map there was painted to look like the surface of Mars. And so what we did was we took a Lego robot and we kind of built the base of it, and we handed students, said, okay, well, what would the Mars rover Curiosity be doing on Mars? What kind of tasks would it be, performing? So we talked about it might be taking pictures. We also talked about it collecting soil samples and rocks and things like that. So what we're going to do here is we set up a simulated activity where we wanted to design a rock collector for analysis. So you can see those little cubes that are on there. Those cubes are our Mars rocks. And so we basically gave students a bunch of craft supplies and said, you're going to take the Lego robot that you see here, and you're going to design some sort of front-end edition that is going to be able to collect rocks for us. So this was really us extending the learning and making it more real for the students to really give them a task that could actually be happening. So we took them through the engineering design process with this, and so what you're seeing as a result, now this student right there collected a whole bunch of Mars rocks, which is awesome. I would tell you that 90% of the students the first run collect absolutely nothing. And so they really do learn about the design process and how to go about making those changes, learning from failure. So again, you could do an activity like that. It's just a design challenge. There's a great way to really put an emphasis on the learning. You want to make sure you do reflection after this, because that's where probably students are going to really learn the most is, okay, let's look back on what worked, what didn't, what process did we go through. We also like to incorporate novel engineering, not only with some of our low-tech supplies, but also the high-tech robotics as well. So if you're not familiar with that, think about any story you're reading in an ELA classroom. Think about any real person you're studying, and whether it's a science classroom, social studies classroom, they've all had problems that are trying to solve or did solve. So with novel engineering, we go through and we try to engineer a solution, for example, and that can be with any product. So you'll see in the bottom right, we have some students doing some work with the Lego WeDos. So we gave them a task. They had to design a rover that would go ahead and move some objects for us. We've done this, with K1 using things like fairy tales. We can do this pretty much with anything. And when we're doing these things with robotics, we put a huge emphasis on obviously engineering design, but also invention. We want students to be creative. We just don't want them to grab a Lego book, follow the directions, build it, and be done. We want to teach them the basic skills and then let their imaginations go so they can invent. So again, when we're talking about our design processes, we're using these as a prototyping product. So they may have done the research and now they're actually getting to build that. We also love to incorporate number sense when it comes to mathematics. So when we're using those Lego EV3s in the upper right, we actually give them a sheet of paper that kind of tells the students, okay, for every time the wheel turns, it's going to go this many inches. And so we have another challenge that we do where they're trying to pick up Mars rocks from set distances. And some of them are as long as 200 inches away. Well, they're really having, and we don't give them enough help on our little chart that we give them to actually, be able just to look at the chart, enter in numbers, and be done. They're really having to think mathematically of, okay, with the numbers I've been given, how can I take those and extrapolate that out to make sure I know how many tire rotations I need to go a certain distance? And so that's been a huge thing, is really showing students, here is the math that you're learning in class. Now let's apply it to robotics, really making it meaningful and useful. And then the bottom there you see success skill development. Anytime we do activities with robotics, we are working in groups. We need students to learn how to collaborate. We need to make sure they know how to communicate and really listen to each other's ideas and work together and just persevere through the problems. And so that's kind of just a side benefit of anything that we do with robotics. And as long as we're using something, an instructional model that really stresses student invention, they're going to put these skills into practice. So a couple of resources I want to share. If you want an example of the lesson that we did with the Mars rover, you can see that there. I referred to that EV3 reference chart. Excuse me. So we actually had a volunteer who was an engineer take those robots home and create that chart for us. So that's something that you can go ahead and replicate and use. And then we included some other resources there that you see that are straight from Lego and straight for VEX. You want to look at their curriculum resources. Excuse me, thank you. All right, let's continue on. So I kind of have a second class of robots. These robots are truly all about programming. So there's much less emphasis on design, and now we're really getting into programming. So most people are familiar with Sphero, Ozobot, and Dash and Dot at the bottom there, but not everyone is as familiar with Cubeto in the upper right. So I point that out in saying if you're a K1 teacher, Cubeto is an awesome tool to use because you don't need a computer. You don't need anything, you just need what's exactly that comes with it. They also give you a mat, so basically it's a grid, and so you can work on some map making skills there as well. So we get into these robots, again, we want to make sure they're tied to curriculum and we're just not having fun driving Sphero around. So what you see on the right there is this was an activity with third graders, and again, this is getting into more of the simulation realm. So they were studying the moon. And so we painted some mats to look like the moon, and you'll see those orange dots on there. So students actually had to program their robots to get to those dots. And we did it a couple different ways. We kind of told them they got bonus points if you could land it right on the orange dot. But if you could drive it over it, we gave you enough credit for that too. And so we talked about this being a simulation because when we put rovers on the moon, again, very much like the Mars rover, we're probably going there to collect scientific data, study areas, take pictures. So we kind of layered on top, these are the points of interest that we want to go, and you've got to get your robot to those spots. We tried to paint some craters on there to tell students kind of go around the craters. And so this is where we started bringing in that computational thinking that we talked about earlier, because when students start programming or coding, they've really got to think computationally. They've got to figure out some students will realize that, you know what, I don't have to hit all 5 dots in one program. They can decompose and say, you know what, maybe I'm going to break this up. I'm going to write smaller programs to get to 1 dot at a time. Not every group figures that out, and so it's a great way to talk about computational thinking and ways to break down this challenge. They also have to really think about patterns. So if they can figure out, okay, this worked to get to one area, how can they then replicate that so that they can be consistent time and time again? And that's where, again, and then once they come up with their code, they're kind of writing that out. This is also a great way to apply geometry and, again, work on number sets. We can do lots with angles on here. We can do lots, again, working with multiples and things like that, so students understand when they double something, how is that going to affect the distance that it travels. We've had a lot of teachers do things with mapping and directions as well, especially with things like more along the lines of the Cubetto, because it comes with a map. But we've had teachers make charts with letters, charts with numbers, or just working on kind of more of a coordinate system. So I've got to get this to A2. How am I going to do that? Or I need to get this now to C2 on the map. And so those are all, again, you can bring in some real life applications with these. We've had with the Ozobot, students actually recreate and retell stories based with the Ozobot as the main character, so it kind of travels through scenes that students are making. So again, they're having to take what they're learning from reading and then apply that more into the scene area, and then we just use those to stress the coding aspect of it. So again, you'll see those students are all working together with a partner, and so they're communicating, they're talking, they're problem solving, and we want them to continue to do that. So here are some resources if you want to look at those for Sphero, Ozobot, Dash, and Cubetto. Great resources to check out if you're looking for lessons to kind of just get started. All right, so again, if you have things that you've done with these that you want to share, send those ideas to me at iTechBob on Twitter. I would love to hear about them and add them to the repertoire of things that we do, and maybe I can share something else as well. All right, so I kind of moved this one up a little bit. So this is kind of my area where I've been geeking out a little bit, is getting into the microcontrollers and coding. So if you're not familiar with microcontrollers, this is one of the new ones that's out there, and this is called the microbit. The thing I like about this, first of all, it's inexpensive. So that device that you see on the screen there is all of $15. $20 if you buy it with like the battery pack and things like that. But these allow you to not only get into programming, but also make it more physical computing as well. So for example, you can make a wearable out of this. If you use conductive thread, you can sew in LEDs, and they can go into where you see this 0, 1, and 2. And you can even actually, if you're really good, you can actually attach them to these very small pins as well. So you can adjust the LEDs here. There are built-in sensors on here. So there's actually, and you can plug in external sensors. So I could actually make this be able to chart moisture. And there's a temperature sensor on here. This thing has a compass. It has an accelerometer on there. So there's all these new sensors, so allow you now to take coding and do a whole lot more with it. So when you think about students prototyping solutions, this gives them a way to create a physical prototype that they can also program. And that's when we talk about what's the good instructional strategy to use with this. Yeah, they have some great projects to get you started, but students can be so creative with these products. So there are some pre-done lessons that are out there. There's a great one on probability that you can program this thing to do rock, paper, scissors, which is really kind of fun. And then there are some automation projects, things that it will just do automatically for you. And we're starting to see the kind of the ecosystem build up around this. So about 3-4 weeks ago, I actually saw a robot that was probably about a foot long, so a decent sized robot, actually being controlled and run by a microbit. So microbit is just one of the microcontrollers that's out there. The Circuit Playground is another. Again, works very similarly. It actually has, I think, more capability and power. It's also a little bit more complex in my opinion. So these are areas that I'm really starting to dive into, so I'm really curious if other folks are using this. What kind of things are they doing? So the great thing about this is you may not start there. Maybe you want to start with Makey. It's something that's a little bit more maybe easier to get started with. Your students may be more familiar with that, but then you can pair that with Scratch programming to create some really cool things with the Makey. And again, I'm creating physical prototypes. So if I'm going through the design process, the Makey is really just there at the end. It's not the star of the show. It's just part of maybe this project that I'm doing, and I'm going to make something and I'm going to program it so that it does something. You can also take advantage of things off code.org. So we're used to the hour of code and things like that, but you may want to check out the game lab, the app lab, and the play lab, because those are things where, again, students can create. So when we talk about creating a final product, when we talk about creating a prototype, if they're doing something that's digital, they could go ahead and do it there. So I kind of put a couple examples in this slide, and again, you'll have access to this presentation that you can click on those. So the kiosk demo is one that actually works with Makey. So you can kind of see it's an example of something we do with the state of Missouri, where basically you can turn anything that you physically make and have it control what's on your computer screen, kind of like you're at a museum. Then I put a science demo on there as well. So if students want to showcase what they know or make a teaching tool, they can actually code that in Scratch. And so we've already kind of done that on there. So some other resources, Make Code. If you're not familiar with Make Code, that's where you actually go to program the microbit. And so I've also put some microbit projects on there. And then Circuit Playground also has some great tutorials that are used for that. And if you're not familiar with that, it also gets used with the new code.org CS Discoveries curriculum. That's more of their middle school and up curriculum. And so one of their units actually deals primarily with the Circuit Playground. So definitely check that out. All right, and again, I'm in definite need of ideas here. So if you have something, please feel free to share. So then we get into the electronics and engineering. So Little Bits and Kiva Planks. The thing I love about these is they are meant to be combined with other things, and they're simple. They don't require any tablets or laptops or Chromebooks or anything like that. So, and one of the things I love about Little Bits is they are made to combine with other things. So I always say they're great for electrifying your cardboard creation. So if you're creating your prototypes or you're solving your design challenge and you want to add a little something to it, you can add in the Little Bits. So in the picture you see on the right, we did this with Novel Engineering. We did this with Grandma trying to get away from the big bad wolf. And so what you see there in the middle is Grandma, who is actually on the bed, and the bed has a little trap door. So when Grandma needs to slide out so that she does not get eaten, the Little Bits actually, there's a servo underneath there. It moves. That door actually drops down and Grandma slides to safety. So again, it lets you add a little bit more sophistication to some of the things that you're doing when you're doing novel engineering, when you're solving design challenges, or when you're creating a cardboard prototype. The Kiva planks we love to use for dealing with force and motion. Again, they're great for building structures, so there's all these little Kiva plank challenges you can do to build the tallest structure with the fewest amount of planks. We use them for lots of ramp activities, so again, can deal with some force and motion there. And they're great for making mazes and angles. So we looked at the dash and dot earlier, or we looked at the Autobot. We've had some schools have good success combining that with Kiva planks, so that students could then work on different angles and then writing directions and tying that into language arts. So some cool stuff. So again, we put some activities on here, some Kiva Blank challenges, and then Little Bits does a great job providing tons of resources, so you can kind of check those out as you have time. So Bloxels is another thing that we use. I'm not going to go into this one too much because it's really it's a video game creator, but there's so much you can do with it. Like, I could probably talk for hours about all the things you do with Bloxels. So it is great for giving students an outlet to create something to show what they're learning in the content areas. I've seen awesome games on science topics, on social studies topics. I've seen ELA stories retold, and again, this lets students maybe show what they know in a very different way. Doesn't tie into some of the long-term big design projects that we talked about, but it could. This could be the prototype that someone does. So Bloxels, again, I also like the extensions with this. So, in the creative writing, like you may have to write the advertisement to sell your game. Can you build a business model of how you're going to kind of put this game out there and publicize it? So there's lots of different aspects. You can take a simple game and make it bigger. And Bloxels does a good job providing just some sample lessons, but truly this is all about creativity. So the last thing I put on here is the 3D printer. So some people think in the STEM rooms and maker spaces, like this is the piece of equipment you have to have. And I love my 3D printer. I'm not gonna lie, it's a great product, but it's not a necessary product. I always tell people it's a rapid prototyping machine, not a rapid production machine. So don't think that you're gonna be able to create something for everybody really, really quickly. But this is great for talking about prototyping, whether it's an engineering design process, whether it is in design thinking. So one of the coolest examples I saw with this was out of a 6th grade classroom. They were in their science classroom. They were talking about pollination, and I think talking about the bee issue with the bees population dying down. The students actually had to create artificial pollinators. So if we had to manually pollinate plants, we could. And so they took that into a 3D design software. I believe they used Tinkercad, and they were able to create these models. And again, as a classroom teacher, you don't have to print everything that students make. Sometimes I think there's incentive to say, you know what, we're only going to print the best 3 to 5 based on whatever the scoring guide is, whether it's based on student votes, outside votes, anything like that. So that's a way you can really tie in the printer to not making more than just nameplates. Everyone seems to make a nameplate as their first project, and that's great for our first project. But we've got to move beyond nameplates and beyond trinkets and beyond fidget spinners, really getting students to design something that's going to solve a problem. One of the coolest things I've seen probably this year, students made a really simple design. They got tired of their table being wobbly, so they actually made a table extender for the leg so that it would go ahead and make it even. I'm going to confess, I took that idea and did that for Thanksgiving so that we had 2 tables butting up against each other, and we did that to raise the height of one of the tables so that both tables just seamlessly fit together. One of the other cool projects we've seen, again, students were already doing a project in a social studies classroom, and they were doing board games. They actually then designed and printed their game board pieces because they wanted to add some authenticity into what they're doing. So 3D printing fits really well into the engineering design process and into the design thinking model, and truly even the project-based learning model for that final prototype or product that you're taking a look at. And some resources there. One at the bottom I'll point out, Enable the Future. If you've not seen this website, they actually do prosthetic design for kids, and it is awesome, and you can actually get those designs for free. Can be a great way to showcase how 3D printing is really being used in the real world, so definitely check that out. Well, we have gone through a lot. I hope you're not feeling like the guy there on the right. But I just want to tell you, first of all, thank you for, if you're watching this, thank you for sticking through the end. You've got my contact information on there. I do want to point out actually 2 other links, one being the tiny URL. I created a website that we're using in our district to help teachers and students learn about how to use all the different products that we looked at today. And there also is going to be a collection of lesson ideas. So that will be an evolving website, but you are more than welcome to use that. And those videos, again, will be updated. Lessons will be updated. And then you can see here at the very, very bottom, I'm covering it up right now, but that's all right. There is actually a URL that you can get to this presentation. This presentation will be in view mode, so you're welcome to view it, make a copy. You may want to look at it to get some of the links, things like that. So thank you for sticking with me. I hope you enjoyed this session. Again, if you have any questions, feel free to reach out to me.